Okay, hello there. This is week one of semester two. This is media and climate change. It's me, but it's not me. Look at this. I'm sitting. I have a lava lamp, brand new, testing it. It's actually a present from my son for Christmas, and some pictures on the wall. So my idea, and look, I'm not wearing a shirt and tie. So my idea is that I'm going to have sort of try and have two personas. One is this is the media and climate change persona, and then you're used to the other, which is me standing up wearing shirt and tie, and just you can see the room. So I know it's kind of meaningless and a bit superfluous, but it actually is as much for me as it is for you. I think I need glasses at this distance because normally when I'm standing, I'm further away. So what I'm going to do today is, this is obviously a pre-recorded lecture. I'm recording it the week before Christmas. I am going to give you a bit of an introduction to media and climate change, the module that we're going to be doing. You will notice that by the end of this, that it is lightish on facts and on precise detail of what we're going to do. There are many reasons for that. One is that simply I'm overworked. Everything I'm teaching this year is new, including this module, and I'm just not managing to keep up to date with it. But my glasses are crooked. But there are other things, such as there is a COVID outbreak among my in-laws, and that has kind of just screwed up things in general in most of my life. So that everyone's fine so far, but that's just complicated. So look at the lava lamp. So the idea is to give you something to look at while I'm boring you over here. Now I'm going to show you some, I'm actually going to show you a PowerPoint slides because I can do that. I'm recording this on Zoom, and I will give you a good idea of what we're going to do, but I'm going to start this week, or in this introductory lecture, by kind of sketching out roughly what we'll be doing, but also I'll be sketching out kind of the kind of the deeper, more difficult sort of philosophical questions that we're going to be tackling in this module on media and climate change. One of the things that you will be required to do is to basically read some science, which I know is not your field. It's not something that you might not be, it's something that you might not be used to. But I've got a couple of things that I'd like you to read from journals such as Nature and Science that are relatively digestible. And actually the problem of reading science and then converting it into some kind of media message is part of what we're going to be learning about. How do you make that transition from moving something from something that is really difficult to understand to something, or that is very specialized, excuse me, to something that is kind of accessible and understandable and on message. So that transition is going to be something that is important to us in this module. But like I say, I want to start with kind of some kind of high concepts. The file I'm going to open now is a PowerPoint file. It'll be on Blackboard, so you can look at it simultaneously. If I do a share screen on this, it should put me in the corner and have the main file visible, and it should be like this. Yes, it is. Okay, so excuse me. This is a 5-credit module. It is a core module. You might have thought that it was an elective. That had been the plan, but things changed with not with this module, but with something else, and it meant that a knock-on effect was that this is a core module. Which is kind of which has kind of changed things a bit from how I planned them, because I had planned that the people who would be doing this module, on average, would be more interested, more knowledgeable, more sort of maybe committed to the idea of climate change or thinking about climate change than the average student. But as it is, I've got all of you now, and for all I know, I've got climate change skeptics among you, or I've got people who find this a real turnoff, or I've got people who find this too distressing to think about or to talk about, which is actually one of the things we're going to talk about. The sort of emotional and sort of, what would you say, kind of mentally taxing realities of climate change. what are you going to do about them? There are, there's more than climate change as things to solve. Another thing to solve is how you react to it. Okay, so this picture that we're looking at, this painting, I will get back to it. It was painted in 1817, the year after 1816. I know you know that 1817 is the year after 1816, but I'll just sort of plant that idea in your mind for the moment. At 1816, it would be interesting to me to know whether any of you knows anything significant that happened in 1816. It's kind of, it was an unusual year in terms of the natural world. So I'll get back to this painting. I've got a few paintings by the same painter, the same romantic painter. When I say romantic, I mean it was a kind of capital R romantic, part of the romantic movement. I'll talk about that in a little bit. But actually, I'm going to start really quite strange, and I'm not going to start with climate change at all, but I want to get you into kind of a conceptual frame of mind. This is Google Maps. It's an image of part of Ireland. This is part of the West Coast. You can see we're looking at Mayo basically, and Sligo, and a bit of Donegal, a bit of Galway. So I wonder, can you see my mouse moving? You probably can. So look, North Atlantic Ocean, okay? So Dublin is over that way. Now, I'm gonna just go through one or two slides here to zoom in to this area here, okay? Just bear with me, all right? We're moving in. There's a place there called Easky. There's a river here called the Easky River, which leads northwards up and flows into the ocean there. Let's move in a little tighter. Okay, Easky's now just up here. This is the village of Easky. It's a small Irish village, west of Ireland. Nothing particularly notable about it. There is no obvious climate change aspect to this until you maybe look down to the right and at the bottom, and you see down here Easky Split Rock. So the Easky Split Rock, maybe some of you have visited it. It's a little, very minor sort of tourist attraction off a road that goes across the north of Mayo. It is a rock that is split. That's what we mean when we say a split rock. So I want to just consider this phenomenon of a split rock as a way of thinking about knowledge about the natural world, because a lot of what we're going to talk about in this module is what do you know about the natural world? What is it possible to know about the natural world? What different ways are there of thinking about what the world is made of? So what's your relationship to rocks? What's your relationship to trees, to the land, to the ocean? Most of those things you're probably actually quite alienated from, in the sense that you don't really have particularly strong feelings about rocks and trees and the ocean. I mean, you might like them, and when you're on holiday, you appreciate them or whatever, but you're mostly, concerned with other things on the whole. And I know you guys kind of well enough to kind of know that that's a broad generalization, but it's generally true, I think, that that's the modern way of being. Most of you are city dwellers, or at least you spend a lot of time in cities, kind of separate from nature, and you don't usually consider your relationship with the natural world. And that's not surprising, because that's what it is. That's one of the things that it is to be modern, is to have a kind of slightly broken relationship with nature. So getting back to the split rock. What is the split rock? Well, let's have a look. There's a noisy truck coming outside my window. Just maybe you can't hear it as badly as I can. Okay, so let me carry on. This is the split rock at Easky. So if you stop at Easky, or just before the village, and look in the field, there is this massive rock. Now, there are two ways, well, there's more than two ways, but there's two main ways of thinking about this rock, of describing this rock, okay? Now, if you're a scientist, and the way that scientists describe the world is going to be very important when we're talking about climate change. If you're a scientist, you say, okay, well, this is a boulder. This is a boulder that is of a certain size. It's 6 meters long, 2.5 meters high. 2.5 meters, it's big. 2.5 meters is, you know, a tall person with their hands up in the air, like where they would touch would be about 2.5 meters. It's basketball hoop sort of height. 6 meters then is, you know, pretty long, a large vehicle, large like van. So that's what a scientist would describe it as. A scientist would tell you that this is a chunk of gneiss, Gneiss, which is a kind of, you know, one of the types of rock that scientists, that geologists talk about. And they would point out that actually this is a kind of an anomaly, that the rocks around this area are not made of gneiss, but this one is. So what happened was that there was a glacier in the Ox Mountains, which is to the south of this point. And at the end of the last ice age, the glacier melted and the glacier receded northwards. And as it receded, it dropped bits and bobs and big chunks of stuff that was in it. And one of the huge things that it dropped was this rock, which presumably split afterwards, or maybe it was split already when it dropped. So I'm looking up at another screen here just to make sure I'm actually talking about what I want to talk about. So that is one sort of scientific method of understanding the rock. Now, the thing is, for most of human history, people who have lived near this rock and known about this rock had no idea about glaciation, had no idea about geological time, or about the ways of naming or defining rocks by the ways that, you know, are they made of sedimentary rock or igneous or whatever. And I'm hopefully churning up some kind of junior cert and leaving cert geography here, because that's how we are, that's our relationship to the modern, or to the natural world. Now, so that way of thinking about it, that scientific way of thinking about this rock, is a relatively recent thing in human history, in world history. We have not always thought about things such as rocks in these scientific terms. And actually the stories that get told about rocks like this, and you might know of other rocks that you might have come across, because these types of things are scattered around the country. There are folklore descriptions of rocks such as this. This one is known as Fion's stone, as in Fionn McCool. And the story that's attached to it is that Fionn McCool was down in the Ox Mountains, which is the place that the scientists say the glaciers came from. Fionn McCool was, had a huge hurl, and he was banging rocks off the Ox Mountains out towards the sea, and this one fell a bit short. And he was so annoyed that it fell short, he came running up with his sword, and he walloped it with his sword, and he split it. So, because the giants were having a stone throwing or stone hitting competition, and he felt, you know, he was annoyed that he hadn't won. He hadn't hit the sea. So that's how the split rock of Iski got there. And local tradition has it that if you walk through that crack, because that crack is big enough for you to walk through, kind of, you know, just about squeezing through, you have to kind of turn your shoulders a bit. The story is, if you go through this rock 3 times, that it will snap shut and kill you. And there's another story about when that rock opens wide enough for a donkey with baskets on it to pass through, then it's the second coming of Christ or whatever. It's all kinds of pishogucht is what they call it, or folklore stories about this rock. Okay, so first of all, we have a way of describing the rock in terms actually of climate change, of like non-human climate change, as in when the glaciers retreated after the last ice age. So hopefully you can kind of see some connection there to what our themes are. But at the kind of the slightly more kind of deeper level, what I want you to kind of pay attention to here is, how has it happened that our beliefs about the world, about the natural world, have changed over time? Because obviously those stories about Fionn McCool and all of that, we know they're not true. Like in our rational scientific minds, we know that that's not true, that those things are made up, that they are fantasies. But we also know that they were told and believed. I don't know if they were literally believed. It's hard to know what other people actually believed in previous times. But we know now definitely that we believe that there was an ice age, and that that rock was somewhere else and that it got carried there by glaciers. So we know what we believe. It's hard for us to know what other people believed. And we do know that a change happened, that there was at one time one set of beliefs and now there is another set of beliefs. So how did our beliefs change? And the way that people's beliefs change about the natural world is of interest to us because climate change and media, the presence of climate change in the media is nearly always a question of belief and changing people's belief, trying to convince people that it is true, or possibly convince people that it's not true, which is something that some people are very busy doing also. So how does that change in belief come about? That's one of the things I want us to be talking about for this module. When did we start believing in science? Now, I'm not saying science is just another belief like religion or something, although it kind of is, but I'm just pointing out how we believe in science, how we have quite deep faith in science, generally speaking, in medicine, in geology, in physics, and so on. I need a drink, hang on. And do we really believe it? Because it's kind of nicer and more interesting and more memorable to think of this split rock as having been thrown there by Finn the Fool, instead of it being something that belongs to your junior cert geography curriculum. So what is our relation to the natural world? That's a core issue in this module. Do we human beings, do we Irish modern human beings, or at least modern human beings living in Ireland, do we believe that the world is there for us? Do we believe that it has been provided for our benefit? Is it there because of us? Is it there despite us? What's our position in the world? Are there things on the world, things that inhabit the world that are more important than us? Are trees more important? Is soil more important? Is the air more important? Insects? Or can we separate them out? Should we think of the whole thing as an entire organism? Are the rocks more important than us? What does more important mean? If something lasts longer than us, well, definitely the rocks are more important than us. But if that's what it is, if something is vaster than us, well, then the air is bigger than us. So who are we in relation to the earth is kind of the question here, in relation to the world. Now, the reasons these are, we're not by any stretch the first people to start wondering about these questions. I'm going to move on here to this again. Now, this was the opening picture, our painting. This painting is called Two Gentlemen. What's it called again? I'll have it on the next slide. It's an 1817 photo painting, and the artist's name I'll show you. Actually, I'll move to the next slide now. The first one is called Two Men by the Sea, 1817. This one is called Wanderer Above the Sea of Fog, from the following year, 1818. And then the next one I'll show you in a minute. So I'm going to go back for a sec. Two Men by the Sea, 1817. Okay, now it's a pity we're not actually, I'm pre-recording this because I'd like to know if anyone knows this painting. This is a painting by Casper David Friedrich, a German painter of the Romantic tradition. The Romantic tradition is usually, we position it around 1800 to 1850. It exists in painting, it exists in sculpture, it exists in poetry. I suppose most sort of prominently of the English speakers, Romanticism is a kind of poetic thing. It's Wordsworth and Shelley and Keats and all that stuff. And Goethe, another, it's a world, or at least a Europe-wide phenomenon. So what you have, a very common thing that Casper David Friedrich does in his paintings throughout his life, I'll move ahead to show you, just to kind of note the similarity between this one and the next one. What he often does is he positions us behind somebody who is looking at nature. So we are looking at nature. We are observing, in this case, the rocks, the clouds, the height of the mountain and the amazing, whatever view. And we are looking at another person who is experiencing something similar to us. And often we are viewing them sort of from behind. So we're kind of it's almost like a point of view shot in cinema, but of course we're a long way pre-cinema here. But you can kind of see what he is trying to show us is not just nature, but the human being in relation to nature. And so this is somebody very typical of the Romantics who is interested, yes, in nature, but also interested in what is the relationship between the human being and nature. What is the relationship between you and the split rock at Easkey, or to trees when you go by them and don't even notice them? I'll move to the next one, which is called Moonrise by the Sea. And again, you can see the same artist doing something similar. We're looking at people who themselves are looking, excuse me, at a natural scene. This is from 1822. So an important question for the Romantics was the question of whether, my notes are kind of backwards here, it's annoying. Okay, an important question for the Romantics was, let me just hang on a second, alter something so that I don't forget to mention it later on, because I want to make sure I don't. Sorry, I know you're looking at me, kind of reaching over you. Okay. God damn it. Okay, so an important question for the Romantics was this question of, are we part of nature or are we separate from it? Because the Romantic period, this 1800 onwards kind of period, is a period when, especially looking back, we can observe that there was kind of a fork, a kind of separation in general European attitudes towards nature on the one hand and human nature on the other. And the two things started separating in our minds. That humans started to become thought of as not actually quite part of nature. So the Romantic tradition has it that we are in nature, and you see these people, these stand-ins for us in natural settings all the time. So they are in nature, but they are not of nature. Nature is actually a separate thing. So this is the modern mindset that we pretty much still live with in different ways. At the modern attitude towards the natural world, that nature is sort of out there and that we ourselves are not quite part of it. Now, like, we know that we are apes and we know that we eat food and or eat the earth, and we know we're made of space dust. We know all that, but what we feel, broadly speaking, actually is that we are not part of nature. Because if you ask, kind of casually say, well, what's nature? You will say trees and rocks and the sea and crabs and insects and all that. And you won't include humans in that. Almost by definition, humans are not part of nature. Nature is everything that's not human. So that's why I'm showing you these paintings. But there's another reason I want to show you these paintings. And it is, oops, this one in particular. And the year of this, The Two Men by the Sea, this was painted in 1817. Look at the color of the sky. Look how much red there is. This was painted the following year, much more blue and white. And this one was painted a few years after that. And again, we're in the blue, white, and kind of gray spectrum. So why is there so much red in that painting? It kind of seems like a banal question. It was a very red sunset that evening. Fine, okay, we get it. But in 1816, the year before this was painted, there was a significant geological event on the other side of the planet. So 1816, the year before this painting, that red sky painting was done, is known now as the year without a summer. It's also known as 1800 and freezing, which is kind of funny. So what happened? There is a mountain, there's a volcano over in the Philippines called Mount Tambora. Is it Indonesia or the Philippines? Philippines, I'm pretty sure. It erupted in 1815. It spewed up so it was the most enormous eruption for probably about 1,000 years. And there hasn't been anything like as big since. It spewed up so much dust into the atmosphere that it blocked sunlight, not just around the area of the eruption itself, but globally. We have our best records about what happened as a result in North America and in Europe. But broadly speaking, looking back, looking at different ways of measuring things such as cutting trees down and looking at their rings and so on, the consensus is that there was a global temperature change of -1 degree centigrade in the year following, in 1816. Now that's an average, okay? And something that we will be learning about is that when you average, when you talk about averages in terms of global climate, you actually are kind of skewing the real data, because if the average is -1 degree centigrade, what actually could be happening is that you might have -8 in one spot and +4 in another. So there is a kind of a wild vacillation, because -1 doesn't seem very big, but suddenly -8 does seem big. So if you have a cold winter's night these days in December in 2020 is about 2 degrees. So 8 degrees lower than that would bring you down to -6. That's pretty cold. It'd be pretty cold for us now. So imagine living in a world where there is, there's no central heating, there's no insulation, there's no, most people live in crappy little mud huts and are on subsistence diets anyway. So it's a significant change. Europe gets a very, very cold year. There are storms, there's abnormal rainfall, and crops fail throughout Europe. There is famine all over Europe. Typhus outbreaks, because people are then, typhus is always kind of there in the margins. When people got sick, typhus kind of moved in when they got, their kind of defenses were down. Huge, basically incalculable death toll as a result of this 1816, this year without a summer. If you're interested, you can click on that link there. It's a 45-minute sort of program about the year without a summer by some historians. It's kind of good, very succinct. So, so what's going on? There's low solar activity because the dust goes up into the air, into the high atmosphere. Sun cannot get, the normal amount of sun cannot get in onto the surface of the earth. There had, in fact, before Tambora in 1815, there had been a chain of other eruptions, 1813, 1814. So there already was slightly more dust than usual. And so what you have, what we understand now, looking back, is that there was a global cold snap as a result of an eruption of a volcano. And so what we're looking at is climate change. Way back in 1816, not human-caused climate change, and the word for that is anthropogenic, caused by humans. It's not anthropogenic climate change; it's natural climate change in this case, of a once-off event. It's not the kind of climate change that we describe in terms of kind of ice ages and all that, which operate on much slower cycles. It's a once-off sudden event. So when you are a European person of science, where the scientific kind of method, scientific way of understanding the world that we have now, when that starts taking hold in and around 1800, and you look at the skies for 1 year in this weird year of freezing temperatures and mass death and a lot of fear, you look at the sky and the sky is blood red all that year, and these amazing, beautiful sunsets apparently. And it's connected to the writing of the novel Frankenstein, which we can, actually, I think it's in that radio show. We then see European humans looking at the atmosphere, looking at the globe, and trying to interpret what is actually going on here. They start looking at this phenomenon, not like people used to look at the split rock of Iski, as in many of them stopped thinking about things in terms of, oh, the gods are angry with us, or we shouldn't have waged that war and now we're being punished for it. They started thinking in terms of, well, what's the air made of? And what are the bits that are in the air? And why does light go red when it goes through certain substances? And how did this dust get up there? And you slowly get this consciousness of, oh, well, if there's an eruption, then dust goes into the air. And so what causes an eruption? Well, then you get the whole science of geology and seismology, volcanology, and you get scientific interpretations emerging of what seems to be, or what are natural events. So the relationship, again, just to reiterate, the relationship between humans and the natural world is beginning to change. We're now looking at nature in a different way. We're applying a kind of scientific method to it, and thinking about it analytically, categorically. So this is something that is to be interpreted in terms of science. This is also the early 1800s. This period is also the beginning of industrialization, which is when all the stuff starts going wrong that leads us to climate change now. This is when humans in Europe started digging coal out of the ground, started felling forests and extremely at an industrial scale, and started living in cities, and started basically the fossil fuel economy, industrial economy that we have now still. This, when you look at the statistics of climate change as it is now, they will always start at around 1800 or 1820 as the beginning of the industrial era. So all of that scientific knowledge, all of that way, that analytic, categorical way of thinking about the world, thinking about, well, what are metals made of? How is their boiling temperature? How can we move coal from here to there? How much can you load on a boat without it sinking? All of these, what does density of materials mean? All of these ideas, what is electricity? Can we harness it? That's all in the kind of intellectual air at this time. And the year without a summer provoked a whole set of kind of interesting reactions to this weird phenomenon of especially the reds that were in the air at that time. There's an article here, I'm showing you the title of it, by Zarufos et al. The article is called Atmospheric Effects of Volcanic Eruptions as Seen by Famous Artists and Depicted in Their Paintings. And it's in the journal Atmospheric Chemistry and Physics from 2007. Now, this is not the kind of journal that you guys are used to looking at. You're more used to looking at, you know, media and society and all that kind of stuff. Some of what we are going to read this semester is going to be quite far outside your, I don't want to say comfort zone, such a tired phrase, but it's outside your normal realm. You will find yourselves having to look at things such as atmospheric chemistry and physics. Not just because I want to kind of, you know, push you into areas just to kind of broaden your minds in a kind of educational way, but not just that, but also because I think it is, in order to understand climate change, you have to be able to understand scientific writing, and you have to be able to not be totally intimidated by it and not see it as something that is outside your ken. Doesn't mean you can understand everything that comes up in these journals, but at least you can open them up, read their abstract and get the gist of what they're on about. That's a link to this article, and I've got a quote from it here. And when you read this, you go, yeah, actually, I could understand that. So what they do in the present work in this article is, the present work aims at providing a new look at the reconstruction of the aerosol optical depth before, during, and after major volcanic eruptions. So aerosol, like suspended in the air, we know that word now because it's such a big COVID word. Optical depth, so how much kind of does light get blocked by aerosol particles before, during, and after major volcanic eruptions by studying the coloration of the atmosphere in paintings which portrayed sunsets in the period 1500 to 1900, i.e. when atmospheric observations were scarce and mostly non-existent. This was done by measuring the red to green ratios of more than 500 paintings, as well as using model calculations to simulate and calibrate the measurements from the coloration in paintings as described in the following text. So that's just an excerpt of that article. Sorry, my throat is sore. I've had a cough, as well as everything else. I've had a cough. Hang on. I'm drinking matcha tea, green matcha tea. Nice. Okay. So, I'm going to give you an overview of the module. These slides will be more full of more specific material when we meet again. But I'm going to briefly tell you what are the themes that we're going to talk about. The images that are in them, I will also sort of talk to you about them somewhat in somewhat more detail when we get together in week 2 of this semester. But I'd just like to point out that the images that I'm showing you here, especially from this point on, are all, well, I don't know, I don't know how to connect. They're all fossil fuel images. We tend not to think of, you know, a painting, a beautiful, delicately executed painting of 2 candles or something ethereal, spiritual about them or whatever. But these are fossil fuels. This is paraffin. This is humans burning the earth and creating excess carbon dioxide. It's everywhere. It is so deeply ingrained into our culture that we often don't see it even when we're staring at it. So a candle is something that causes climate change. It's an absolutely minor thing, but it is there. That's what it is. Paraffin is a derivative of oil, basically. The painting's by Gerhard Richter, the German painter. So, overview of module themes. The first, and they're not necessarily in the order we'll come to them, but exponentiality is an important one. So what does that mean? If something grows exponentially, we understand that, I think, it's not growing in a linear way, but it's growing in an exponential way. So linear growth would be, say, you know, you save 10 euros a month. And so after 2 months, you've got 20 euros, and after 3 months, you've got 30, and so on and so on. That's linear. And you can predict in month 1, if I save 10 euros a month for 50 months, I'll have 500 euros. That's linear growth, linear expansion. That's not what we're talking about. Exponential is when you are growing at a much less calculable way, much harder to predict kind of way. So exponential growth, in fact, COVID has given us a very kind of live instance of that, where you can have, 50 infected people. You can't predict that 50 infected people will become 150 the next week. It could become 150, but it could become 1,000. You just don't know quite what the rate of growth is. So the R number, as we talk about it. So exponential growth is, to use the kind of, to describe it in terms of mathematics, it's to do with when you have the little number up the top. So x squared, x cubed, x to the power 4. You're talking about things growing up to the power of x, okay? So exponential growth is a problem for humanity because we tend not to understand how quick exponential growth can happen. And so we, especially in modern capitalist societies, we tend to talk about growth a lot. We tend to think that economic growth and growth of GDP and growth of wealth are good things that are a good indicator of how the world is changing and how human society is changing. But if something grows, say at 7% a year, then after 10 years, it doubles. That's a problem if you're talking about temperatures, and it's a problem if you're talking about human populations. So understanding rates of change is an important thing that we're going to talk about in this semester. Trying to visualize them. We will be talking about data visualization actually in our media analysis, media criticism, module, and there will be a little bit of crossover between these two modules. In that respect, how do you visualize change? How do you describe change to yourself, to others? What would you do if you had to present some scientific evidence? How would you graph it? How would you show it? These are some of the things I want us to talk about. Okay, moving on. Wake up, computer. Technological solutionism. Okay, so solutionism. Solutionism. If you are looking for a solution for something from technology, then you are a believer in technological solutionism. So if you hear somebody say, we can work out a technological solution to the problem of climate change if we sequester enough carbon in the soil by doing this, or if we build enough wind farms, or if we switch to electric cars, or if we, whatever the solutions that you hear are. The idea that technology can provide us with a solution is the belief in technological solutionism. The problem with technological solutionism is that it exhibits a deep faith in technology as something that will save us, where we know that technology is the thing that got us into trouble in the first place. And our deep faith in technology is the thing that's got us into trouble in the first place. So technological solutionism is something you need to be very, very wary of, very, very skeptical of. And it is the most common way for governments, institutions to describe what they are doing in relation to technological solutions, in relation to climate change. Now, you might quite reasonably ask, well, how the hell else are we going to get out of this? And okay, fair enough. That's a good question. One answer might be, we're not going to get out of it. We are going to slam into a wall of climate change. In fact, we already have started hitting it. There is no solution. And what we have to do is actually work out how to survive it. That's one quite pessimistic way of thinking about it. But it's one that is becoming more common. Or we can believe in solutions provided by technological changes, but we can be skeptical about who is providing those solutions, who is promoting them. And so when you find yourself parked, in a traffic jam behind a Nissan Leaf and it's got a little green leaf symbol at the back, and you think this car company is presenting itself as the solution to the problem of car companies and petrol and emissions, then you need to be very, very skeptical. The painting is by Ed Ruscha. I'll give you all these names at a later date. An American painter, no surprise there. Okay, move on. Apocalyptic thought and eco-psychopathology. Yes, I have used a word with eco-psychopathology, an 8-syllable word. Apocalyptic thought. Okay, I think you can understand that when you think about the apocalypse, when you think about the end of the world. We are not the first generation of people to really think that we are facing the end times. People have thought this for a long time. This time, it's probably for real, or it's more real than it was before for previous peoples. But there is a history of apocalyptic thinking. There is a history of visions of the end of the world. And we're going to look at them. We're going to see what is the kind of tradition, what is the historical tradition that we are at the end of. Eco-psychopathology. Okay, well, let's break that down a bit. Eco is connected to the environment. Okay. Pathology is to do with suffering, illness. Psychopathology is to do with psychological suffering, to do with psychological illness. So eco-psychopathology is the suffering that humans experience as a result of ecological change. So anxiety, fear, panic, hopelessness, things that are so powerful that they actually will prevent you from thinking about climate change at all, because it's so overwhelming. How can you possibly do anything? How can you possibly survive this? Eco-psychopathology is a way of describing a whole set of films, books of different kinds, like fiction film, novels, poetry, that is becoming kind of a bigger and bigger genre. And we'll be looking at some of them, of visions of climate change end times. One we might look at is Snowpiercer, a movie called Snowpiercer from a few years ago. Another one is called Take Shelter from about 10 years ago. Another one is, the name has gone out of my head, it's a Lars von Trier film, and it's got Kiefer Sutherland in it, and it's about a planet or an asteroid about to suddenly collide with Earth. God, what's the bloody name of it? It's kind of weird because I really like the film. I can't remember the name. Anyway, there is a list of films that we are going to consider. I'm going to point you towards novels and things like that that are about this that I actually don't know much about, but maybe some of you would be more interested in them. So that's one of the things we'll talk about. Okay, moving on. Wicked problems and super wicked problems. Okay, so the painting here is by Gerhard Richter, who did the candles, same artist. Wicked problems and super wicked problems. What's the time? How long have I been talking? Doesn't matter. Wicked problems are, this is, believe it or not, kind of quite a technical term used in mostly in kind of mathematics and in sort of engineering and so on to describe problems that are close to being incalculable, close to being unsolvable. So often you'll get sort of things like board games, kind of like chess and Go and those kind of things. The problem of developing a solution to chess is regarded as a wicked problem. Okay, it's just so difficult to solve for a machine that it's referred to as a wicked problem. Super wicked problem is a kind of an adjustment of that, a kind of expansion of the idea. And a super wicked problem, I'll get into this in more detail, obviously, when we get close to the time, but a super wicked problem is a way of kind of broadening the wicked problem idea into a slightly more sociological space. And it's a way of describing problems that are apparently unfixable. And they are unfixable because we are intervening too late. There's a few criteria. One is that we're intervening too late. One is that the people who are trying to solve the problem are the same people who caused the problem. Another ingredient of super wicked problems is that there is a failure to recognize the scale of the problem, and so on and so on. So there's a kind of list of criteria, and climate change is kind of a good example of a super wicked problem. One that is, even though we kind of know what ought to be done, at least in the broadest sense, yet we cannot actually achieve that solution. Because there are all kinds of institutional and psychological kind of blockages on the way. So we're going to talk about them. Let me move on. We're going to talk about planetary boundaries, and I'm going to just, planetary boundaries and resilience in the Anthropocene. Excuse me. The Anthropocene, probably most of you are acquainted with that idea, but it's one that I'll spend a bit of time talking about anyway. The Anthropocene is the idea, if you ever see anthropo, that prefix anthropos, the Greek word for, ancient Greek word for man, or let's say humans. The Anthropocene is the period, the geological period that is dominated by humans. So not the Jurassic and not the Pleistocene, not the Eocene, not the whatever other ones there are, but the Anthropocene, the one that, in the future, if there are any other intelligent beings in the deep future, and they will go down through the rocks of Earth, and they will find this level, and they go, what happened at this level? And that level we're now calling the Anthropocene. So human impact on the environment is so massive, so deep. It is happening to the Earth itself, and we are leaving an indelible mark. So that's the idea of the Anthropocene. Planetary boundaries and resilience. So resilience is the kind of the key term that tends to be used for people who are already basically thinking beyond climate change, in the sense that they're thinking not so much in terms of how can we prevent climate change, but more in terms of how can we survive climate change? What can we do now in order to make ourselves resilient to a climate changed world? Planetary boundaries is a kind of a quick phrase for trying to cover a slightly new way of thinking about CO2 emissions, where we tend to think about climate change nearly entirely in terms of CO2 and a little bit about methane and other gases. But there's kind of new thinking developing which emphasizes that you can't isolate those gases as being a kind of a single problem that we should tackle, but actually there are a lot of boundaries to what to the planet's resources, and we are in danger of exceeding many of them. So another one would be fresh water, for example. So if we exceed our fresh water boundary, we're screwed. If we exceed the CO2 boundary, we're screwed. So there are multiple boundaries that another one's to do with biodiversity. So there's 9 of them according to this particular Planetary Boundaries Institute in Sweden, which I will talk about. And so it kind of contextualizes the kind of decarbonization debate into a kind of a broader context and says, well, actually, it's as important to make sure that you leave the leaves in the corner of the garden for the insects to live and the fungi to grow and everything as it is not to use your car. Or, that's a bastardized way of talking about it, but you understand what I mean. So you have to think about many, many actions that you take as a human kind of operant on the face of the earth, not simply in terms of, am I producing CO2 or not? Painting is by Lowry, Lowry. It's a painting of Manchester. That's the Manchester United ground, as was. Ireland and climate change. I actually am not quite clear on exactly what to do in this lecture, so I'm going to push it a little bit down the term. I've got a book arriving, which hasn't arrived yet, on exactly this subject, so I'm a little bit inexpert, but I think one thing that I will enjoy talking about is the Climate Case Ireland group, Climate Case Ireland, which is a group of activists who are of Irish people, or at least Irish residents, who are bringing the Irish state to court for failing to meet its commitments to the Kyoto protocols and for basically screwing up the future. So that's kind of an interesting way of doing it. Ireland is a very poor performer on the climate change scene in European terms. Why is that? How long can that keep going on? We kind of cut ourselves an awful lot of slack after the recession of 2008 to 2011, where we said, well, we have so much debt and we have so many other problems, we can't think about the climate. And so now we've sort of, inverted commas, solved all those other problems, and yet we're still not thinking about the climate. So Ireland is an interesting case. And it's interesting, obviously, for us. How will we survive it, given that we are people who live in this particular little island? What are we going to do without the Gulf Stream? If the Gulf Stream breaks down, Ireland is going to turn into northern Canada kind of temperatures. We won't be able to live here anymore. Certainly 5 million of us won't be able to live here anymore. So what are we going to do then? Okay, moving on. In a more general way, and these are big themes, okay? And actually I should have put this first, but I wanted us to talk about science, and I wanted us to talk about power and knowledge and trust and truth. The power-knowledge pairing is an important one. It's very closely connected to the thinking of Michel Foucault, French kind of philosopher, who we will look at and get more acquainted with. The power knowledge idea is, it's not simply that, knowledge is power, which is, obviously there's kind of truth in that, but it's to do with the structuring of knowledge. And if you look at the way that knowledge is shaped, the way we describe the world, then you're also looking at how power works. So when you say that's not a rock that was hit there by Finn McCool, that's a piece of gneiss that was left there by glaciation, yeah, you're describing, you've got different kinds of knowledge, different categories of knowledge, folk knowledge versus scientific knowledge. But Foucault points out that's not just sort of two kinds of knowledge, there's two completely different power systems going on there. You have one set of people who have authority, in whom we have trust, who we believe who tell us folklore stories. And then you have another set of people who we believe and we have trust in and we have faith in because we think they speak the truth because they are scientists. So all of these, so we believe the Fion McCool story and we believe the gneiss receding glacier story about the same thing. So power and knowledge are inseparable. They are always kind of compared. Not compared, but compared. The screenshots here are from the film Zoolander. I don't know if anyone has seen Zoolander. It's not a film about climate change, but it's a film about people who have a kind of a mess kind of water fight, except it's not water, it's petrol in a petrol station. It's a very funny scene, and you probably know it. All right, and let me bring things to an end here just by mentioning, oh, other pictures I haven't used. There you go, other pictures I haven't used. To do in the first weeks, right? So in week 2 and week 3, we are going to be concerned with these. So I'm kind of giving you notice now. Watch the film An Inconvenient Truth from 2006. Yes, it's 14 years out of date, 15 years actually by the time you watch this, but that's the point. I want it to be slightly out of date. Excuse me. I want you to watch it. We are going to discuss it. We're going to discuss it. It's the Al Gore sort of climate emergency film. We're going to watch it and talk about, well, how does he make his arguments? How does he present his truths? There's that word truth again. How does he try to get us to believe in science? What is the kind of the apocalyptic thinking that is going on there? And a lot of the themes that I've just been describing are present in that film. So I want you to watch that film. It's quite easy to get. If you can't get it, send me an email and I'll send you a link to it. But it's easy to rip. It's not an obscure film. It's the old film, so to speak. There is a sequel to it, which is called, I think, An Inconvenient Sequel. That's not the one that, I mean, you can watch that too, by all means, but the one that is important for us is this one, An Inconvenient Truth from 2006. There are 2 things to read. One is there and the other is there. All right, so the first one is a good deal shorter and simpler than the second one. They are both, one appeared in the article in the journal Bioscience and the other appeared in the journal Science. They are from 2019. They provide basically the kind of latest or almost the most up-to-date kind of scientific consensus, a climate scientific consensus that is available. And the exercise that I want to kind of put you through is to watch a film from 2006 and then to read the science in 2019 and to update the film. To say, well, in An Inconvenient Truth in 2006, which was actually made in 2005, Al Gore is predicting this and he's predicting that and he's projecting this and he's saying that this is going to happen. What do we know now, 16 years later? Or 17 years later, about the changes that have actually happened and the kinds of predictions that are now being made about the near future. The reason I'm doing this the reason I want you to do this is to kind of make you think about change, that change is not simply something that is being predicted, but change is something that is actually happening at a very fast pace. So our knowledge about climate science is actually itself changing. Another reason I want you to do this is these 2 articles here will give you a very kind of firm grounding in kind of up-to-date climate science. These will be kind of 2 sort of foundation stones for you being able to sort of have at your fingertips the kind of a good, succinct summation of the major things that are sort of at stake in climate change science. So they're foundational pieces of knowledge for you guys doing this module. So you need to know it, and you need to know it throughout the module. So they're the first things I'm giving you to read. These are, I think, I can't remember how available they are when you click those links, but anyway, the 2 articles are available as PDFs, excuse me, on Blackboard. So watch the movie, read the articles, and a brief word about, is there anything else after this? No, blackness. So a brief word about continuous assessment. I'm going to make an effort, a real effort, to get a lot of your CA tasks done as early as possible. And I will give you detail on this when we meet again, but my rough thinking is this. You are going to have 4 separate CA tasks, each worth 25%. The first one will be due in week 3 or 4. The second one will be due about 3 weeks after that. The third one about 3 weeks after that. And that means that when you get to week, say, 10, you will have done 75% of the CA for this module. So it will come in chunks, okay? And the first chunk, will be dealing with this film and these articles. So you need to watch this and to read these articles for your CA, and you need them in order to be functional in class in the first couple of weeks. Okay, so that's all I've got to say. I'm going to stop sharing. This, what I've just shown you, this PowerPoint thing is on Blackboard anyway. So I better stop recording this before my computer goes on fire. So you will have had a happy Christmas by the time I see you all. It will be 2021. Today's the solstice. It's the what's the solstice? I don't care, because I'm a modern person. I don't need to know when it's the shortest day of the year, because we have electric light. See, we have electric light. We have computers. We have all these things that totally alienate us from the natural cycles of things. But it is the solstice, because there are some people like myself who have mothers who tell them about that when they're kids. We'll also be talking about trees a lot during this module, as a way of kind of trying to understand your own personal relationship with the modern world, with the natural world. I want to talk about trees. I want specifically to talk about the trees on the IADT campus. Every week, we're going to talk about a tree, a particular type of tree that is on the campus. And after 12 weeks, 13 weeks, you will know about 12 or 13 kinds of trees. You might not remember them all. You might already know 10 or 12 kinds of trees, but fact is you probably don't. The differences between trees, the difference between a birch and a beech and an oak and an aspen and an alder and an elder and an apple tree, these are not important differences for living in a modern society. They're the kind of things you learn when you're about 5, 6, 7, 8 years old. And then when you grow up, well, it's not kind of grown-up knowledge, so you kind of jettison it. Unless you're somebody who's really particularly interested in trees, or you're somebody who works in, you know, some kind of industry connected to trees. It's not important information. So if I stood 100, or let's say if I stood like 25 meters from you and I held up one phone, I held up another phone, and this is an iPhone and this is a Samsung, you would know the difference. You would be able to say, oh yeah, well, that's an iPhone, that's a Samsung. I can tell the difference at this distance between these two things. That's because that's an important difference for living in 2020 or 2021 in Ireland, the difference between iPhones and Samsungs. If I stood beside an oak and stood beside a sycamore at the same distance and asked you what was the difference, most of you would have absolutely no idea. So that's important. It's important to know what you don't know. It's important to recognize what parts of the natural world have been sort of shuttered away from us, and we voluntarily participate in that. We think that mobile phones are more important than trees. I mean, if you really ask me about it, well, yeah, no, I know they're not more important. We need trees more, but the fact is, you spend 999% or whatever the figure would be, more time devoted to mobile phones than you ever do to trees. So they are more important. And so what happens? What is our relationship with nature? That's the kind of question I started with. It's the question I'm ending with, and it's one that I'm going to kind of keep coming back to. And I want to, one thing we're going to maybe discover is that it's very hard to learn about trees because it's hard to care. It's hard to kind of not think that I'm wasting your time. I've shown other students in other contexts things about trees before, and I encounter like frank hostility. What are you doing? You're wasting our time. I want to be educated here. I want to get a job in media after this. I don't need to know the difference between an oak and an elder. People get really annoyed, and some of you are going to get kind of annoyed. Now, this is the time wasting bit. This is the baby bit. This is the 8-year-olds gluing autumn leaves to a page bit of the course content. Yes, it is. And I'm going to do it provocatively. I'm going to waste your time. I'm going to make you a bit annoyed. And that's deliberate, because I want you to understand that you have a value system. It's not a good one. It's not a bad one. It just is a value system. And in that value system, trees and the natural world are not important. And just realizing that will help you understand what your relationship is to climate and climate change as well, hopefully. Right, so that's it. I'm finishing. I hope this made some sense. I'm going to stop the recording and I will talk to you all in person in week 2. Okay, nice to meet you all. Bye-bye. Talk to you soon.